in this video. Hello everybody, and welcome to the 53rd video on the channel. This is another one of these things that I would definitely like to say. This is an introductory trigonometry video, that's why it's still under the topic geometry, and it is one of the most important theorems for proving advanced geometry theorems. I explained a little more about that in my last video, the law of cosines, so make sure you go watch that. It's not an essential primer to this video, but these two topics are closely related and are pretty much used to solve a lot of advanced theorems and a lot of trigonometry problems. So what we're going to do is we're just going to go right into it, but before that, please make sure to like, subscribe, and hit that notification button for more awesome videos just like this. So let's go. Alright, today's lesson is about the law of sines, which is another very important geometry concept which is used in proofs. So I would definitely like to explain this. So if we look at the equation on the top, it says sine A divided by capital A is equal to sine B divided by capital B is equal to sine C divided by capital C. Now I used the individual capital letters to denote each of the sides, and the opposite angle to each side, I make sure that that's the lowercase letter, but it's the same letter. So angle A, which is lowercase, the opposite side is the capital uppercase A. Same thing for B and same thing for C. So I thought that was definitely very necessary. And it's actually quite simple. It's just a relationship. It's a ratio. And there are multiple proofs of this theorem, but I'm going to do a slightly simpler one, which is mostly based off just straight up geometry instead of trigonometry. But it does involve a little bit of trigonometry so please make sure you go watch the video where I explain all of the trigonometric functions, because you're going to need that. So that's going to be good. Alright, and let's start the proof. Alright, first let's see the vertex where you have angle C. Let's draw a line. First, let's erase the C so it's easier. So let's draw a line here, down, and that intersects the side C. Now that's perpendicular. So now we're going to call this the height. So what we're going to say is, okay, so how do we define height in terms of others? So if you realize that this is a hypotenuse, this is an angle, and the height is a vertical, you'll realize h divided by a is equal to sine b. So h is equal to a sine b. And if you do that for the other side, you'll get h divided by b is equal to sine a. So h is equal to b sine a. So since these are both the same thing, you can just set them equal to each other. So h is equal to h becomes a sine b is equal to b sine a. And all you have to do is rearrange to get sine b, not capital B, lowercase b. Sine b divided by b is equal to sine a divided by a. So that's one part of it. So now let's do that again for a different vertex, and that's going to prove the theorem. Because what you're gonna see, if we're gonna prove sine B is equal to sine C, that means sine B is equal to sine C is equal to sine A. That means sine A is also equal to sine C. So that just proves the whole theorem. So let's do it really quick. I'm gonna write it in red and cut it out of the video because I think you get like the more of the basic idea right now. And I think it would be a lot simpler if you did that, because otherwise it would just be really cumbersome. And of course I'll explain it. So if you have any questions or comment, please say it, because I guess this is another time for shameless plug. I really appreciate it, and it really helps this channel a ton. So let's all see you when I'm done writing the rest. Alright, that was pretty simple. So all I did was I just wrote the rest of the steps. So we're gonna draw a line from vertex A onto side A. So we're gonna call that line Z because H is different. So if we just do the original formula, Z by C is equal to sine B, Z by B is equal to sine C. Of course, lowercase and uppercase as needed. And then you solve for B, set them equal and rearrange as shown on the screen. Just like we did last time, you'll pretty soon figure out that that's about how it is. And since we have sine A is equal to sine B and sine B is equal to sine C, that proves the theorem on the top. And I think that's a pretty good proof. I really like this proof. It's quite simple, it's easy to understand, and it doesn't use as much trigonometry. So, see you in the next one. Bye-bye, and thanks for watching.